you need when you're 3D printing. One, you need a 3D printer. Two, you need a 3D model. And you also need some control software. So to make 3D models, you can use all kinds of software. Now, one we like to use is either Blender 3D or another one called OpenSCAD. Now, there's two bits of software we use to actually control the printer, to print things out. One of them is called Slicer, and what Slicer does is it essentially takes your model and it creates ultra-thin layers of the model that can be translated into the layers that the printer prints. A piece of software called Interface. I guess somebody just took printer and replaced the O, replaced the I with the O. But this is essentially the software that translates the sliced 3D model produced by Slicer into the movements that the printer needs to do to print out the 3D model. So anyway, I'm going to show you a little bit about Blender, and then I'll show you a little bit about slicing models and hopefully printing one. It's called a G-code file. The G-code file is the instructions for the printer that Interface will use to guide where the nozzle is at a particular point. At the moment I'm running the latest versions from the source code. You can actually download it as an actual program. But as I said, it's written in Python, which is a scripting programming language.
The things with the electronics of these printers though, is if you have a memory card, like an SD card for instance, on a phone, you can actually plug it into the printer controller board and print directly off that. So you don't need a computer for the files.
It's going to take a little while to start printing because it needs to bring the extruder head up to around 200 degrees. You'll notice, is it showing on the TV? It should be recording the temperature as it goes up. That's sweet. So once it hits around 195 degrees, it will start moving everything into place.
There's actually a thermostat, a temperature regulating was a resistor, and as the temperature rises, it can send that data back to the computer.
So here we have the start, and
now if you want a closer look, please come up and have a look.
It's got a good jump on the nozzle. Right, it came off. That kind of stuff is problematic. So it's when you get these lumps of plastic like that, it can cause problems.
It will just pick up the rest.
I just stuffed it. It usually does happen at the beginning. So most of the problems you will get right at the beginning of the print.
What it's doing here is cleaning off the head, hopefully.
It always picks up that crap from the end. That's what happens. It needs a little bit of calibration, but it should go this time. So these are the kinds of problems you get with these kinds of printers. It's all fun and games. Oh, it's putting it down quite nicely. So as you notice, the model isn't entirely in the centre there. That's because of my configuration for the... And this is the bit where it usually, if it's going to go wrong, this is the bit where it usually goes wrong on the first couple of layers. If you get through this on the first layer or two, then you're pretty sure the print's going to work.
And what about power consumption?
It's not that bad.
Well, that's a laptop power supply essentially. So you probably get away with about 60 watts.
No, more like 120.
Yeah.
To be safe, these motors will they draw 1.8 amps each. So So they're 12 volt, so times 12 volt by 1.8, which is for 5 motors. 12 by 1.8 is what, 22, say.
90.
Yeah, yeah. So you're looking at it's 90 plus you've got the hot end as well, which will draw at least in the 30 watts.
So even because I think I've seen at least one which has gone like bad with battery power and you can transport it.
Yes, you can.
You can.
You can minimise these. You can make them a lot smaller. You're making your print size smaller as well. But the possibilities to do that are very, very, very rare. A couple of printers have actually been sent into near Earth orbit while printing on under hot air balloons and stuff weather balloons. They've printed and then fallen back down to Earth. They're still printing on it. It's not going down to the steel atoms itself. It's not atomic level printing. That was actually for atomic level printing, however, was first achieved in 1973 by IBM, and they made little men. They actually made a print of a little man in atoms, in iron atoms. It would take 20,000 of these men linked arm to arm to be the width of your human hair. That's the next level for printing to get to, is the atomic level of printing. The 3D printer, yes, it's the same printer. It's called a direct laser disposition printer. The rocket engine which they printed out was mostly ceramics, very specialised ceramics, and the reason that they were able to do this was because it's the first time that they were able to get the temperature of the printer surface itself up to kiln temperatures, so firing temperatures which would normally be associated with putting a ceramic parts to make them hard, I should say. That's where this process has now been able to be replicated.